So today and tomorrow we're finishing up with our standard in regards to simple multi-step equations. But I'm still checking for attending to precision. Make sure when I ask you for an answer, don't just say, oh, the answer is 3 and 5/6. No, x equals to that or whatever the case. Also, we're still looking at using area models, so make sure you continue focusing on that. In our objective for today, I can solve multi-step one-variable equations involving proportions. So now we're going to get into proportions. Let's read together. 1, 2, 3. Multi-step proportions. All right? So once again, make sure you make a note of this. We're going to be looking at proportions. This is something you guys already saw. Some of you saw last year. Some of you saw the year before. I remember I saw these when I was in kinder, but, you know. All right. So, I mean, I saw them, but I didn't know how to do them, but I saw them. All right, here we go. So, we already know we don't need a fair model because we know what one-variable equations are, right? We don't need steps because we already know the steps. What are our 4 steps? Simplify. Yeah, so we're going to continue with that. So we don't need steps. So I just need to clarify some terms, though. On the Q side of your notes, write this down, please. Q side, I want you to write ratio, and for definition, only write what I underline. Ratio, comparison of 2 quantities. Comparison of 2 quantities. And then, as an example, you're going to write these that I box. A to B, A to B, and A to B. Comma, and then at the end you just write where B cannot equal to 0. Copy that, and I'll elaborate a little bit more on that. So, this is how we use ratios fairly often, but people are like, oh, that's a ratio. No, I mean, they're used very often, and sometimes we use them almost on a daily basis when we compare stuff. For example, if I was to say, let's compare students in this class, and I said, let's make a ratio of comparing girls and boys. Therefore, we need to know how many of each, right? Count them off, please. Only count the people that are here. Don't count the people that are absent. Yeah, they don't count. Let's forget about it. Oh. I mean, not like that, but I'm saying that they're not. Okay, let's see. Do we have a number now? 14 what? So you write, as an example, let's write 14 girls.
I got 15.
15? Okay, let's see. 2, 4, 6, 8, 10, 11, 12, 13, 14, 15. Ah. Okay, 15 girls to how many boys? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. To 10 boys. Well, guess what? This is a ratio.
Did you tell yourself?
I'm not a boy. So, check this out. So we're counting students, and I said girls to boys, and this is a ratio. Does everybody understand? Mm-hmm. And look how they write it. A to B, did we write that? Girls to boys. Yes, A is 15 girls, B is 10 boys. What is the other way that they write it? So you write 15 girls, colon, 10 boys. But how is it read? You can read it as 15 girls to 10 boys. That's what the colon means, to. What's another way, the third way?
15 girls over.
Exactly. 15 girls over 10 boys. Those are the three ways that we can write a ratio. However, who notices that when we write a ratio, we wrote it using the same type of, let's say, item. For right now, I'm going to say item. You guys are not an item, I know, but I'm saying the same type of item. Everybody with me? So that's how we can use ratios. And you're saying, wait a minute. What's that?
Like apple?
There you go. So let's say I brought a basket. You don't have to copy this. And in the basket, I have apples and oranges. What kind of items are those? Fruit. So therefore, since it's fruit, I can write a ratio because it's the same type of item, but we're comparing apples and oranges. Everybody understand? Okay, that's a ratio. So, next one. Copy this next term. Proportion. We're still on the Q side. And once again, if you have your colors, use your colors. Proportion. And the easiest way to write the definition is two ratios that are equal. And in this case, they're using fractions for ratios. Who sees that? Everybody see that, right? Okay. So here we have a fraction equal to another fraction. Proportion. Yeah, copy the example. Proportion. Two ratios are equal. Example, 1/12 equals to 2/24. Do you guys agree with that proportion? Yeah, because if I wrote it the other way around, 2/24s, if I reduce it, it becomes what? 1/12. Let me give you another example. What if I had 2 6s? What would this be reduced?
4/12. Wait, reduce 1/3.
1/3.
But couldn't it be 4/12?
It could be 4/12, yeah, because if this one will be the one reduced than for the other. Yeah, I guess we can do that. But for right now, I'm thinking more on reduction because I'm headed somewhere with this. Okay? So, you'll see right now. So, does everybody understand that a proportion is one fraction equal to another fraction? A ratio equal to another ratio. And they're equal. Does everybody agree that this is equal to that, this is equal to that?
Yeah.
All right. The way it's written with algebra, it's written like this. A over B equals C over D. Fairly simple? Yeah, right? Let me show you what is not a proportion. A over B equals C over D plus 2. Talk it over with your neighbor. Why is this not a proportion? Okay, what did the definition say? Two ratios that are equal. Here's a ratio equal to another ratio. Okay, ratio equal to ratio, ratio equal to ratio. Is this a ratio equal to another ratio? No, this one has plus 2. As soon as you add something to one of the fractions, it's no longer a ratio. Okay, so therefore this is no longer a proportion. Are we there so far? Okay, let's move on. Next term. A rate. Copy that. Now I'm going to do that in red. Rate. Still on the Q side. We're still on the Q side. Here we go. A rate. What is a rate? It's a special type of ratio, so if you want to write ratio, and then you write two quantities, different units. Two quantities, different units. And now you're thinking, wait a minute, okay, I get it. Now I know why it's not only a regular ratio. A regular ratio were what? The same kind of units, right? Remember? Girls to boys. Apples to oranges, same type of stuff. But look at this one. What do we have? Miles and gallons. Are they the same type of item? No, they're two different type of measures. That's why this is called a rate. Rate. Kind of like, let's see, another two type of item example. Oh yeah. Who's seen or who's heard of that competition where they eat like Nathan hot dogs? I don't know if I think it's in New York or in Chicago. They hold that every year, and they go there and they compete to see who eats the most hot dogs at the less amount of time. And there's this one guy that kept winning. He was from Japan, very skinny guy, and I think one year he ate close to I don't know if it was 43 or 63 hot dogs. and I think it was only like in 5 minutes.
Wow.
I know, right?
So we watched the video?
No. Some other time. I'll bring some other time. But anyways, you should have seen him when he started. Like he was like really thin, and when he finished, I guess with the water that because he was dunking the hot dog in water, so they can go in a lot faster. So anyways, when he finished, his shirt was all wet, and you can see his belly like this. Like you can see he totally looked like he was pregnant or something. But it was all the hot dogs that he ate. 60-some hot dogs. What's that? Yeah, he did. So let's say he ate 63 hot dogs in 5 minutes. That is an example of a rate. How can we write that? 63 hot dogs over 5 minutes. Is that different type of units? Yeah, hot dogs and times. Does that make sense? Yeah, so that's another example of rate. Okay, let's continue. Also on the Q side, there's this other one called a unit rate. Same, red, because this is related to this one, to rate. The only thing it's called a unit rate, let me show you why. Look up, please. Look up. Unit rate, this one, unit comes from the Latin uno, which means one. Uno. So notice here. Is this to the lowest measure? Is 2 the lowest measure that we can find in gallons? What would be the lowest measure? 1 gallon. How do we do that? What can we do to 2 to become 1? Divide by 2. So therefore, if we divide 34 by 2, how many miles? 17 miles. That's how we get the unit rate. That's what we call unit rate when it's reduced to lowest terms. And I know in the past your teachers just said, as long as whatever you do to the denominator, you make it into a 1, whether it's you multiply or divide, that's how you get your unit rate, that's fine. But that's another way of approaching it. So, unit rate, just write rate, such as, and then write this example. And then for definition, just write written to lowest terms, and I'll just leave it at that. But just remember that one of the measures has to be to the 1 unit. That's why it's called unit rate or uno. Everybody with me? And this is what they use very often when they sell cars. When they sell cars, when you're, whenever you guys get to buy your own car, when you get to college or so, and then when you go buy a car, you're going to be like, well, how many miles per gallon am I going to get? Because you want to try and save as much money as you can. They're going to say, well, the Toyota Corolla gets 32 miles per 1 gallon. But what if they said, well, the Toyota Corolla gets 64 miles per 2 gallons. So in your brain, you're going to do what? Divide by 2, so therefore 32 miles per 1 gallon. Yeah.
Do you know how many gallons are in the tank?
Yeah. It depends. Some, like small vehicles such as a Corolla or a Civic, they usually have 10 gallons, but they usually have 1 or 2 gallons of reserve that they can fit extra. So therefore, to fill in a tank of, let's say a 10-gallon tank, 11-gallon tank, right now the gas is about $3.50 a gallon. So that's about $38 per gas tank. Yeah.
My brother has a Corolla.
Yeah.
And he paid $20 because I have more than half the gas.
Wow. Well, I still remember when I was going to school up in LA and I was working at a Ford dealership, that I was heading from where I was working. I used to clean cars while I went to college. I needed to get a job that paid okay, but they gave me the flexibility of going to school. So when I was done with work, I would get in my little car, go gas up, and I remember that one year that the gas went down to 88 cents a gallon. I know, I was like, oh, $9. I filled in my little bucket. Yeah, it was crazy. I was like, wow.
And
now it's like 4 times that. Anyways, here we go. So, copy this one down, please. Example 1. It says, example 1A. The ratio of the number of bones in a human's ears to the number of bones in the skull is 3 to 11. There are 22 bones in the skull. How many bones are in the ears? Copy that, please.
The whole thing?
No, just the black and blue text. Okay, here we go. It says, the ratio of number of bones in a human's ears to the number of bones in the skull is 3 to 11. So they're giving us a ratio. But check this out. This is how you can distinguish which number or unit belongs to which. Look up, please. I'm going to start with the color red. I'm going to read the problem and I'm going to say, the ratio of numbers of bones in the human ears to the bones in the human skull. So therefore, here we're comparing which item? Bones, right? But from the ear to the skull. Which is the first one that they mention? Ear. So I write bones and ears. I underline that with red or with one color. So like that I know and keep track which one was mentioned first. From there I use a different color. To the number of bones in the skull. So therefore I underline in blue bones in the skull. So now I know that they're talking about two different parts. But they give us a ratio. Look at the ratio, 3 to 11. Which was the first set of bones that they mentioned? Ears. Which is the first number that you see here from left to right? Therefore, that one corresponds to the ears. Which is the second number? 11, and that corresponds to what? Bones in the skull. That's how you can recognize which one belongs to which. Now, let's set that up as a fraction. So that becomes 3 over 11. Are we there so far? Yes. But we're going to set up a proportion in order to solve for the missing amount. Here we go. A proportion is a fraction equal to another fraction. Let's see. So they give us more information. There are 22 bones in the skull. So I'm going to underline that, but with what color? Blue, because this one is the same type of this one. So, looking at my proportion, where did I place the original bones in the skull? On the bottom, so that means this one goes down here. And what are they asking for? How many bones in the ear? So do we know yet? No. Therefore, we label this X. And last year, I'm pretty sure they showed you cross multiplication, right? Actually, in 5th or 6th grade, right? So I start with the variable. What is 11 times x? 11x equals 3 times 22. That's 66. And do we know what to do from there? Yeah. Divide by 11, divide by 11. X equals 6. But let's answer the question. How many bones in the ear? 6 bones in the ear when there are 22 bones in the skull. 10Q. Fairly simple? Yeah, right? So we're going to do another one, but you don't have to copy all the text. Well, what I want you to do with the next one is help me underline stuff, and then you're going to create your own proportion, yes? Here we go. Example 1B. Copy this, please. Write example 1B, and I'm going to read it, and you're going to set up your proportion. It says, the ratio of red marbles to green marbles is 6 to 5. So, which color am I going to use to underline red marbles?
Red.
Okay, you sure not blue? Okay, so red. To green marbles. What color do I use for green marbles? Green. So therefore, which of these corresponds to the red? 6. And the other one corresponds to the green. Okay. See if you can set up your own proportion. Go with that information. Because at the end they say, there are 18 red marbles, and how many green marbles are there? Go. I know, right? Alright, here we go. So, you set up your proportion. Let's see, you wrote 6 over 5 equals, let's see, where does the 18 go on this side? How about Kylie.
Okay. It's gonna be 18x.
18x?
No, 18 and x over x.
Over x. Okay.
Yeah.
Not bad. All right, hands if you got that. That is correct. Cross multiply. This becomes 6x equal to 90. Divide by 6, divide by 6. X equals 15. Hands if you got that for your answer.
No, I got 15 green marbles, but...
Okay, very good. So therefore, it says how many green marbles are there? You're going to say 15 green marbles.
When there's 18.
Marbles. When there are 18 red marbles. 10 cubed. Hands if you got that. Very good. Okay. Ah, pretty good. Math practice standard number 6 says attend to precision. Very good. Okay, let's move on. What's that? It says 15 green marbles when there are 18 red marbles. It's so clear. Okay, let's move on.
Those things that the teachers give kids with bad handwriting, like you have to hold it, you know?
Okay, here we go. Alright, everybody look up, please, pens down. Now, in the past, they showed you how to do cross multiplication, right? And you did it because they told you that it worked, and that was why, right? But did they tell you why?
No.
Okay, here goes the why. Pens down, eyes up here. Watch. It's, let's say I gave you the fraction 2 over 6. Can I simplify this?
Yeah.
This becomes 1/3. Let's see. How about if I gave you the fraction, oh, I know, 25 over 75. What is that?
5 over 1/3.
1/3. Okay. How about if I gave you the fraction 10 over 15? What is this?
2 over 3.
2 over 3. Okay, so check this out. This is what mathematicians noticed. They said, okay, I understand that this is this. This is this, and this is this. And they continue doing that for all fractions. They say it reduces to that. So does everybody agree that this is equal to this? This is equal to this. So they said, we notice that it doesn't matter which proportion it is, they end up having the same number on each side if we cross multiply. So this is 6 equal to 6. Yes. So then they said, let's try it with this one. This is 30 equal to 30. Hey, they're the same number. And so on and so forth. Let's see. 75 equal to 75, and it worked for all of them.
No.
Yes, it does.
What if like it's like 1,000?
Okay. 1,000 over
4,000.
4,000. All right. So let's see. If we reduce that, let's get rid of some zeros. So it's 1,000 over 4,000. That equals to 1/4. Let's see. 4,000 equals 4,000. What?
What if it's like
That just happened. Anyways, and we can continue like that. So therefore, they said, it does work for all of them. Therefore, let's make it into a property. That's why this property is called the cross product property. Does that make sense?
Yeah.
Because it does work. So therefore, how does that look with algebra? It looks like this. Look up, please. A over B equals C over D. Therefore, this becomes A D equals B C or C B. Does everybody agree with that? Yeah. And that's the product that you're going to use, or the cross product that you're going to use for the homework. So with that said, copy this next one and use this property. Example 2A. And they give us solve the proportion 3 9s equal 5 over m. Go. You have 20 seconds. Okay, let's see. You start with the variable. 3 times m, that's 3m, equals 9 times 5, that's 45. To solve, we divide by 3. M equals 15. Hands if you got that. Okay, let's continue. Next. Copy this next one. Negative 5 over 2 equals y over 8. That's example 2b. Go. You got 20 seconds. Okay, once again, cross multiply starting with a variable. This is 2y equals negative 40. And therefore, this is divide by 2, y equals negative 20. Yes? Okay? Alright, so check this out. Pens down, eyes up here. I'm going to zoom in for this one. Pens down, writing utensils down. Here it goes. Look up, please. Do I have a fraction equal to another fraction? No? Let's see. 6 over y minus 3. This is a fraction. This is a fraction, therefore I have a proportion. Are we there so far? That means that the same property works. And I'm going to start with a variable. The variable's down here. Watch. Boom. What just happened? I distribute the 2 to both terms. This becomes 2y minus 6 equals 6 times 7. Copy that and finish it, please. Example, what was this one? 2 something, yes. 2c, because I wanted to see if, anyways. I know, right? They just come out of nowhere. So from here, plus 6, 2y equals 48. Divide by 2, y equals 24. Pretty simple. Just remember, when you have a proportion, just to distribute the number to both terms. I know, right? Let's go to the next one. Example, yeah.
How would we do the, like,
Copy this one, example 3b. We got g plus 3 over 5 equals 7 over 4. Go. You got 25 seconds. Go. So the first one, when you cross multiply, you should get 4g plus 12 equals 35. Hands if you got that. Okay, good. From there we subtract 12. Subtract 12, we end up with 4g equals 23, Michael Jordan. So at the end you divide by 4, g equals 5 3/4, or 5.75. Hands if you got that. Okay, good. So, any questions with these? Very simple? Alright, so check this out. You're going to have one of these in the homework. Pay attention, please. And this is a rate. And basically, you set up your rate. This says that somebody flipped a pancake 416 times in 120 seconds. So how can I set up a rate? 416 over 120. And they want us to reduce that to a unit rate. That means the denominator has to be 1 second. Does everybody understand? And what can I do here? If this is equal to this, what can I do here? X, cross multiply and solve. Everybody with me? But where I want to get to is percents. Watch. Now the word percent, you guys have seen this before, but what does it mean? Here it goes. And I already introduced it with a Jeopardy game, right? And I said, here's a percent sign. Pay attention to this one. This word can be broken down into two. Per means, or comes from the Latin por, which means multiplied by or times, and the symbol is that. Cent comes from something like this. Who's seen that before? Yeah, right? Alright, and cent can be written as 0.01 or 1 over 100, because it's 1 out of 100 pennies in a dollar. Are we there? So what we're saying is that this represents this symbol. So whenever I write this, watch, 25%, that means that I write 25, and what does the percent mean? Times 1/100, and that's why we multiply times 1 over 100.
Oh, is that why, like...
That is why. Hold on, we're not done. I got one more. That is why when they told you, you just write it over 100. Who remembers that? Your teacher used to say just write it over 100, right?
Yeah.
So watch. I want you to copy this proportion. This one. Is over of equals percent over 100. 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 So watch. In your homework, you're going to have an example such as this. Watch. Look up, please, really quick. Whenever you get to a percent, you're going to write is over of equals percent over 100. So watch. From there, I'm going to rewrite it over here, but without the symbols. The only one that doesn't change is 100. So what is the information that they give me? 30%. According to my formula, where does the percent go? On top of the 100, so that goes right there. What other information do they give me? Of 80. Where does the of go? On the bottom. Which is the only thing that they don't give me? The is, so therefore cross multiply and solve. Your homework for tonight is your worksheet. Worksheet 2-5. Have a good one, guys. Enjoy your homework. There's tutoring today. If I don't see you in tutoring, I'll see you guys tomorrow.
My mom, she has a hybrid Honda, and she